Okay, so this is Unit 1, Day 3, or Lesson 3. Starting out with a warm-up, if you would please work with me through this first part, and then we'll talk about terms as well as factors. So starting out, this is a term. It's like 3x to the 4th power. There is multiplication in here, there are exponents in here. However, the whole thing itself is a term. So if you look at this, they're coefficients. Coefficients are the number in front. So in this case, the coefficient would be the 3. The base, well, the base is what the exponent is on. So here's what I have. I have an exponent here, and it's actually on the 3, or in the x, excuse me, the x. So the x is my base that's going to be multiplied by itself 4 times. So the base is the part raised to a power. So in this case, it's the x. And then the exponent is that superscript number or value. So in this case, it's actually the little 4 up top. So it's the 4. Now when you look at the next little piece, we're going to be talking about how many terms are in this expression. Well, terms, we just said, were like number groupings. Okay? So we have this is a number grouping, and the sign in front of a number grouping goes with it. So this is another one, and then this is the third one. So there are actually 3 terms. Okay? Because there are 3 number groupings. Then now it's asking about like terms. Well, like terms are things that are alike. They have to have the same variable and the same exponent. So I would suggest you start with the highest exponent and work our way down. So I've got this is x to the 4th. There are no other x to the 4ths. Then go to the x to the seconds and see if there are other x to the seconds. And then x's and then plain numbers. And write down the 2 that are the same here. And then write the sum of x and 5. So this is where we're going to translate some words to math. Sum means to add and put it in order. Keep it in order. So it's just going to be x plus 5. And the same thing here, except for you're going to do this one with the difference of 7 and y. Keep the same order, but difference means minus. So write out the expression here. What is the constant? Well, the constant is going to be the number without a variable. Variable. I can't spell right now. So plain number, and remember the sign in front of it goes with it. So I've got x squared, that's a variable. This is plus 3x, there's a variable. So guess what? Just make sure you write it out. Right? Then we're talking about distributive property. Distributive property, we have to take the number on the outside, we're going to multiply it over the inside. So it's going to be the 4 times x, and then the 4 times the 2. So I'll end up with 4x plus, and then 4 times 2, which ends up being 8. So 4x plus 8. Just for these first 2, I would like to see this middle step down to the end. You don't have to consistently, but if you're making any errors, I'm going to have you show that middle step. Same thing over here. Distribute it for me, please. Watch your signs. The area of a rectangle. We're talking about the area of a rectangle is the length times the width. Okay, and that'll end up giving you area equals length times width. So if I give you a rectangle like this, it doesn't matter which you decide is the length or the width. You just have to be consistent. So if you wanted the length to be 8, the width could be 5. So it would be 8 times 5 equals the area. And that would be 40 is equal to the area. And that's actually going to be 40. In this case, it's going to be 40 square inches. So 40 inches with a little 2 on top. This next one, it looks like it got cut off of mine. So write an expression for the length and the width of the partitioned rectangle. Okay, so this one, if I look at this base part, okay, this is like the length, Well, it's going to be a 7 plus x, right? So basically this and this together, and 4. So it's going to be 4 is one side length, and the other side is going to be a 7 plus x. So I could get 28 plus 4x. Or showing that middle step would be 4 times 7 plus 4 times x. And the third one, write the area as a sum of the areas of the smaller rectangle in number 2. Okay, well, the area of the smaller rectangles, well, in this would be a 7 by 4, and this would be an x by 4. So I could say 7 times 4 and x times 4 and add those together. So 28 plus 4x. Now this bottom part, areas of partitioned rectangles, again, what we're going to do is we're going to be putting these into this little table down below. So for each rectangle, write the expressions for the length and the width of the two expressions for the total area. Record them in the table. Check your expressions in each row. Your group will discuss it with disagreements. Well, in this case, we can't really do a bunch of group things. However, we will discuss it when you come back to class, and I'll try to give you some feedback. So in this one, this is a times 3. So this chunk right here would be a 3a. And this over here is 5 times 3, right? Because it's the same thing. So this one is 5 times 3, which is 15. So I have the width of A. I'm going to call it, the width is, I'm going to call it 3, and I'm going to say the length is A. And then the other part of it would be 5 and the 3. So you have choices. If we're going to do the sums, here it says to actually write it as the whole piece. So let's click this. And work with it as an A plus 5 and then a 3. So the width is 3 and the length is going to be A plus 5. Write the area as a product of width times length. Well, the product there would be 3A plus 5. And then area as a sum of them, that means actually distribute it, would give me 3A plus 15 if I distributed that out. So let's try one more. If it's on B, my width I have as 1/3. My length is 6 plus x. Writing it out, I'm going to have 1/3 times 6 plus x. But then if I actually distribute that, 1/3 of 6 is going to give me 6/3, which is 2. So 2 plus 1/3 x. And do number 3, that's a 1 and an r, so r, and then a 1 plus 1 plus 1 is actually 3. So r times 3, which is just 3r. And then try finishing the rest of them on your own. The next part is talking about the distributive property. The models below show two methods for finding the area of a rectangle that has a length of x plus 2 units and the width of 3 units. So notice that I have this whole area right here is the x plus 2, and this is the 3. So then I've got 3 times x plus 2. This one does the same thing. I have an x and I have a 2, so x plus 2. And then the 3, and this is showing it where I have the 3x and then the 3 times 2, which is basically distributive property. So I've got 6 problems right here that I'd like you to do on your own real quick using distributive property. I'll give you a couple little hints. This does go forward. This is the same thing, it's just going to go backwards. So it's still going to be 8 times 9 minus x times 9. And if you can use parentheses or you can use the dot, so 72 minus 9x. Always write the number in front of the variable. Distribute. Again, distribute, watch your signs, because a negative times a negative makes a positive. This is like a 1m. This number right here, this is like a negative 1 times the quantity, so multiply by negative 1. And then this is basically multiplying by half or dividing by 2 each time. So try on your own. Then we have some practice. If 8x plus 20 represents the area of a partitioned rectangle, what could be the expressions for the side lengths? Well, there are a couple different things you can do. You can figure out how can I do some number as a width and then a quantity as the inside. So think about drawing your picture. Because there's an x and a plain number, so we know that we had to multiply by that. Then we have a checkpoint. The distributive property can use the generated equivalent expressions. So I'm looking for equivalent expressions. If 30 plus 12x represents the area of a partitioned rectangle, what could be the expressions for the side lengths? So list 5 different possibilities. So if you looked at this, I'll give you one. You can use it as one of your 5. If I have an answer of 30 plus 12x, I could basically I could divide by 2. If I divided by 2, I would end up with 15 plus 6x. So 2 and 15 plus 6x. That's one option to give me 4 others. Draw a partitioned rectangle to illustrate the following identity. So try looking at this and drawing a picture for that. And that's it.